Our last example is to maximize the function f of x, y, z equals x squared plus 2y squared plus z squared minus x plus 2y minus 3z, subject to the constraint x plus 2y minus z equals 4. So f is the function that we want to maximize, and the function g of x is x plus 2y minus z. So again, to use the method of Lagrange multipliers, we will need to find df dx, which is 2x minus 1, df dy, which is 4y plus 2, and df dz, which is 2z minus 3. We then want to find the partial derivatives of g. So dg dx is 1. dg dy is 2. And gg dz is negative 1. So if the derivative of f with respect to x is supposed to be a multiple of the derivative of g, 2x minus 1 equals lambda times 1. And if the derivative of f with respect to y is supposed to be a multiple of the derivative of g with respect to y, then 4y plus 2 should equal 2 lambda. And then finally, if df dz is supposed to be a multiple of dg dz, then 2z minus 3 equals negative lambda. Okay, so our method has been to always solve for lambda. So we still have, for our first equation, that 2x minus 1 equals lambda. For a second equation, we'll divide by 2, so that 2y plus 1 is also equal to lambda. And for our third equation, we will multiply by negative 1, so that negative 2z plus 3 is equal to lambda. And again, let's remember that our fourth equation is the constraint g of x, y, z. Okay, so we'll begin by the same way that we did in the previous problem. We'll set equation 1 equal to equation 2, so that 2x minus 1 is equal to 2y plus 1. And I will also set equation 1 equal to equation 3, so that 2x minus 1 is equal to minus 2z plus 3. So now in each of these cases, I can solve for y, or sorry, solve for y in terms of x and solve for z in terms of x. So I see that 2x minus 2 is equal to 2y, so that x minus 1 is equal to y. And I will also see that 2x minus 4 is equal to negative 2z, so that negative x plus 2 is equal to z. Now I'm going to plug these two relationships into equation 4. So x plus 2y minus z equals 4 can be written as x plus 2 times x minus 1 minus a negative x plus 2 is equal to 4. And this becomes x plus 2x plus x, so that's 4x minus 2, so minus 4, and that's equal to 4. So we have that 4x is equal to 8. So x is 2. Okay, so now that we know that x is equal to 2, we can get that y is x minus 1, which is here. So x must be 1. And then z is equal to negative x. So looking over here, z is equal to negative x plus 2. That's negative 2 plus 2. So z is equal to 0. And so this is our maximum. So that's the location of our maximum. We want to find the value of f of x, y, z at our maximum. So f of 2, 1, 0 is going to be 2 squared plus 2 times 1 squared plus 0 squared minus 2 plus 2 times 1 minus 3 times 0. So f of 2, 1, 0 is equal to 6, and that is our maximum. So this is the maximum location, and this is the maximum value.